Welcome to qnawire.
To know what is going to be the total capacitance for the following circuit, and in order to do so, we're going to start reducing the circuit as much as possible. So the first step is going to be to consider these two capacitance that are going to be in parallel. Remember that equivalent capacitance, when we're in parallel, is going to be equal to the sum of capacitance. So in this case, this would be C5 plus C6. We're going to call this new capacitance equal to C7. Okay? So after we have reduced this value, what we're going to get is we can erase this part of the circuit. And now, instead of having C5, what we're going to have is C7. This is going to be the equivalent capacitance that we're going to have for that. Okay, I'm going to track all of the values over here just for continue reducing our circuit. Now the next step is going to be considering C1 and C2. These two capacitance are going to be in parallel and in series. And whenever we have capacitance in series, what we're going to have is that 1 over C1 plus 1 over C2. Okay? I'm going to call this new capacitance C8. Okay? So what this means is that this part of the circuit now becomes C8. From now, I'm not going to do any calculation. We're going to leave the calculations until the very end. And the other one that is connected in series is this section over here, C4 and C7. So the new capacitance that we're going to call C9 is going to be equal to 1 over C4 plus 1 over C7. Notice that we are still not doing any calculation. Now, after reducing this part of the circuit, what we're going to get is a capacitance equal to C9. Okay? And now, finally, we have three capacitance that are in parallel, so this circuit is going to be equivalent to a circuit with C total directly, and the C total for this circuit would be the sum of C8 plus C3 plus C9. So we can proceed with the calculations. The first one is going to be finding what is going to be C7. C7 was C5 plus C6, so 0.750 750 plus 15 microfarads, which is 15.750 microfarads. Perfect. Now C8. C8 is equal to 1 over capacitance 1, which is 5.15 microfarads plus 1 over capacitance 2, which was 3.55. This gives us 2.10144 microfarads. Here I'm taking as many significant digits as possible because at the end we're going to cut it up to 3 significant digits because all of the quantities here have only 3. Okay? And finally, C9 is going to be 1 over C4, which was C4, 2.75 microfarads, plus 1 over C7, which is 15.75 microfarads, giving us 2.34122 microfarads. So with this, we can calculate the final result. The total was C8 plus C3 plus C9. Remember that C3 is equal to, just to have it at hand, 6.25 microfarads. C total was C3 plus C8 plus C9, giving us 10.69 microfarads. Or if we want to round up to three significant digits, this would be 10.7 microfarads. And that would be all. Just as a recap, recall that we can reduce the circuits until we have something that is easier to solve. Whenever we have whenever we have capacitance on parallel, the capacitance is going to add up directly. And if we have capacitance in series, we need to calculate the total or the equivalent capacitance as such. So in our original circuit, we had essentially one section that was in parallel, then it becomes two different sections in series, and the final one is going to become a parallel one that gives us this result. So that would be all. Thank you very much and have a good one.